So we have a question that f is a continuous function from interval ab to real number. We are assuming that there are constants alpha and beta such that for any c in the interval integral from a to c multiplied with alpha, integral from c to b multiplied with beta, this sum is 0. Okay, now we have to show that f is 0, that is fx is equal to 0 for every x inside in our domain. Okay, so how to solve without loss of generality? First step, this is first step, step 1, that we can take alpha not equal to beta. Otherwise what will happen? If alpha is equal to beta, then our hypothesis becomes this, where we are taking alpha common. Okay, then alpha into this inside sum becomes integral from a to b fx dx is equal to 0, and this does not implies that f is 0. For example, look at this example, alpha into integral from 0 to 2 pi sin x dx, this is 0, but sin function is not 0. Okay, whatever alpha is doesn't matter, 0 non-zero I am saying in that sense. Okay, so without loss of generality we can take alpha not equal to beta. Now we come to the proof. Now there is a point where fx is non-zero, so we can take without loss of generality fx is positive. Same proof will work if fx is negative. Okay, we can assume. Okay, so now we are assuming that fx is non-zero, hence we can assume that it is positive. Okay, without loss of generality. Now if we take epsilon is equal to fx by 2, then there exists delta by continuity of f such that whenever y belongs to delta neighborhood of x in the domain, f of y belongs to epsilon neighborhood of fx. Okay, note that this is epsilon is positive. Now by our hypothesis, this is the first part of the hypothesis. Okay, this is this bracket I am saying, this is just alpha into integral from a to x plus delta fx dx. I am just breaking the integral into two parts. Okay, now look at this becomes first equation. Okay, now I am breaking this integral into two parts, c being x minus delta. In that case it was x plus delta. Okay, now I am breaking where now this second part becomes, this is just x minus delta to b fx dx. Beta is beta here. Okay, so we have two equation now. If we subtract second equation from the first, you see this part. Okay, let me write this part cancelled with this part cancelled with this. Okay, now in the middle we have alpha minus beta into integral from x minus delta to x plus delta. Okay, fx dx. Now this is contradiction. You see why? Because alpha minus beta is non-zero. We have taken this. Now fx is strictly positive in this neighborhood, x minus delta to x plus delta. This says fx is okay. F of t maybe right. F is, even I can write f is strictly positive on x minus delta to x plus delta. Okay, so this is how it should be shown. there will be some integral if f is strictly positive. So this product alpha minus beta into the integral from x minus delta to x plus delta, this would be either positive or negative, at least non-zero, but we are getting 0 here, so it is contradiction. So what is the problem? Problem is that fx, this fx would be 0 only. If it was negative, then similar proof where epsilon we can take mod fx by 2, same thing will work, and here we will get something. F is negative, graphs will be negative, but depending on this, both are non-zero, so products would be non-zero. This is how the proof is. So we get f is equal to 0 everywhere in the domain.